All right, here we go with the week 23 test. So first we're doing some statistics. We're comparing data sets. So let's scroll this down so we can see the whole problem. And when we talk about comparing data sets, what they're telling us is we have two sets of data and we're comparing them. We're making some comparisons using some standard statistics. In this case, we're using three statistical ideas. We're using the idea of medians. So medians, which are middle numbers. We're using the idea of means, which is what people usually think of as an average. Median is also an average. And we're using the idea of ranges. And range is how far away the biggest number is from the smallest number. So the very first thing we're going to do is we're going to calculate the median for company A, the mean for company A, and the range for company A. Well, to calculate the median for company A, we put all of the salaries in order from least to greatest. And we talked about one way to do that on problems like these that have tables. If the table isn't very large, if there aren't too many numbers, is to simply number them. So in this case, what we did was we went through and we said, all right, this 698, it's the smallest salary. We're going to call it number 1. Then the next salary, whatever it is, next smallest, which is 705, we're going to call number 2, and so on. And we went and did that with all 5 salaries. And when we were done, we knew that the median, the one in the middle, would be whichever was labeled number 3. And our number 3 salary right here was 718. And we brought that 718 down as our median. The next thing we looked for was the mean salary. Now the mean is add everything together and divide by how many there are. So take this entire box full of salaries, take all the salaries here, add them together. So I'm going to go through and I'm going to add everything up. And so I can just look at it and say, you know, I'm doing all these salaries. I'm adding everything right there. And when you add them all together, you get 3,588,000. So we brought that number right down here, and then we divided it by 5, because that's what you do. You take whatever the total is, and you divide it by how many numbers there are. There were 5 numbers in the group, so that divided by 5 gave us this, 717,600. And then finally the range, how far is the largest number away from the smallest number? Well, to get that particular range, we took the biggest salary right here, I'm back in the table now, 735, and we subtracted the smallest salary. So if you took, let me scroll my screen just a little bit here, if you took 735,000 and you subtracted 698,000, I wish I was making either of those amounts. If you did that subtraction, your answer would be right here. Your answer would be $37,000. So we did that for company A. Then we turned around, we did the very same thing for company B. Did the median first. So we went through and did that same process of putting them all in order, least to greatest, finding number 3 right here, and that was our median. Then we did the mean salary, added them all together. In this case, when you add them all up, so if I added all of these together, my total would be 4,199,000. Divide that by 5, I get 839,800. And the range, and in this case, the range would be 1 million. This is a salary I'd really like to make. 1,362,000 minus the 685,000. That's the smallest salary. Even that one would be pretty sweet. And when you subtract those, right there, 677,000. So that's all the facts we need. Now we have all the information to do this problem. So now we're ready to finish it out. A, the median is a better measure of central tendency than the mean for the salaries in B, over here. And that's true. And the thing that tells us that is right down here. If we want to see that pretty clearly, we see it right in this range. That's the advantage of finding the range. Anytime you have this huge range, that tells us, wow, you know what? Because that range is so big, the mean really isn't going to be a very good average. And we can see that if we look at this mean salary, $839,800, and we look back at our chart, the only person who makes an amount bigger than that is the CEO, which means you've got 4 salaries in the company, all less than that. That's not a very good average. If somebody said, I'm going to go work for company B, I wonder what I'll make. And somebody else said, oh, the average salary is $839,800. Holy, I'm going to make all kinds of money. And then you get there and you realize, well, sure, that's the average because the CEO makes so much money compared to everybody else. He makes twice as much almost as the next highest paid person. So A is going to be true. The median will be a better measure. If you look at the median, look at this value, this 703,000, and compare that back to the group, it's pretty much sitting in the middle of everything. It's a better average. All right, B, the median for A is smaller than the mean for A. Well, here's the median for A, 718,000. Here's the mean, 717,600. 718 is not smaller than that, so B is false. C, the median for B is larger than the mean for B. Well, the median is 703. The mean is 839,800. That's the one affected by the outlier. Also not true. And finally, D, the range for B is greater than the range for A. Well, you bet it is. The range for B is 677,000. That's huge compared to only 37,000. So review that. Again, if you have questions, bring them back. This would be a great one to look at if you decide to take an intervention video or an intervention test and you need a video to study. All right, on to question number 2. Question number 2 is our bias question. How do we build a good survey? So first, we know that there is a student council at Pacent Middle School. They want to identify students' favorite subject. I'm not sure why they're interested in that, but they're interested in students' favorite subject. So they decide to run a sample, and they have some conversation, some discussion. They come up with 4 different ideas. Idea A, randomly select 8 students from every Algebra 1 class. Well, there's a bias anytime you pick your entire group from the same subject. You're going to a math class, and algebra is often a class that students, they can choose to take that class, and you're asking them their favorite. Not a good sample to understand what students as a whole want, especially at a middle school. B, randomly select 8 students from every first period class, not just the math classes, not just the PE classes, every class. That's a good sample. That's going to give you something random. C, survey every 8th student alphabetically by last name. Well, that's going to give you a full range of people at the school. So it's going to give you 6th graders, 7th graders, 8th graders, people whose last name is Ramirez, and people whose last name is Smith, and probably not a Wilmarth, because I'm not a student, but you get the idea. You're going to have this wide range of people. That's a good one. D, survey every 8th student who participates in one of the sports teams. Kids who like sports, what might they like? What, PE? They picked PE? We're so surprised. Again, anytime you have a group like that has something in common, you're probably not getting as good a survey as if you make your selection more random. All right, let's move on to the next question. So here's another one of those problems where they run a survey. So they did a random sample. They're telling you sample was random, so you don't have to wonder that. Random sample, 50 students from the school, about the winter sports they participate in the after-school program. This might be like their ACE program. Here's what she found out. There were 7 students who picked basketball, 15 picked soccer, 8 picked volleyball, 20 said no sport. They don't do an after-school sport. So then there were 3 questions asked, or 3 statements made, and Jalen had to decide, are these statements true or false? Statement number 1, 15% of the students picked soccer. Well, somebody might look right there and go, look, soccer 15. But that's not 15%, that's 15 students. To figure out what percent it is, Jalen has to do this little bit of math right here. She has to take the 15 and divide it by 50. And when she does that and gets 0.3, she gets 30%, not 15%. Jalen can say, nope, that's a false statement. B, more students probably participate in soccer than either basketball or volleyball. Well, soccer has 15 students. 15 students picked soccer. If we look at basketball, only 7. If we look at volleyball, only 8. So soccer is the most. Now, some of you picked no sport. And if the question was, what do students like to do after school? Is soccer the number one thing? You could say no. 20 picked no sport. But the question was specifically, do more students do soccer than basketball or volleyball? So the no sport in this case didn't mean anything. It didn't help us at all. All right, to the last true-false question. In a group of 150 students at the school, it's expected that 21 participate in basketball. Jalen says true. Here's her proof. The survey said 7 out of 50 pick basketball. That's 14%. 21 out of 150, also 14%. 7 out of 50, right here. 7 out of 50 is equal to 21 out of 150. So Jalen can say yes, true to that. And down to our final problem, how we get the volume of a prism. So our volume of a prism problem this time dealt with a trapezoidal prism. That really fancy sounding thing simply means that the base is a trapezoid. And since the base is a trapezoid, we use this formula to find its area. And let me circle that differently because I want you to get the drawing in your head also. This formula, and it is base 1, up and down, plus base 2, other side up and down, divided by 2, which gives us the average of the bases times the height. So for this one, here is everything just to get the area of the base. So we have 10 plus 6, 10. Let me change up my colors here so it stands out a bit, since I got lots to pick from. 10 times 6, I got that 6 from right here, I can bring it over. 10 times 6 divided by 2 times 8, which is the height. 16 times 2, 16 divided by 2 times 8. 8 times 8, 64. That's the area of the base. Once we have that, we multiply it by the length, which is this 14. That's the length. And we get our volume, 896 cubic inches. And finally, the extra credit problem, there you go. Is that fish tank going to work? The answer is no. That fish tank that Sophia is looking at will only hold 1,200 cubic inches of water, not the necessary 1,500 cubic inches of water. All right, so there's the week 23 test. And remember, even if you don't feel like you need to go over this test right now, keep in mind that these types of problems will come up later on interventions. And so if you're looking at a 4 and you want to make it a 5, or your best score is a 3.5 and you say, man, I want to get that to a 4, this is a place that you can study.